New implant allows ALS patient to communicate using brain activity. Researchers in the Netherlands have developed a brain implant that's enabled a woman with Lou Gehrig's disease, also known as ALS, to communicate by using brain activity without a doctor's supervision. The electrocorticograph consists of 4 roughly 5 centimeter long electrode strips. Each strip contains 4 small electrodes. The electrode strips are implanted inside the skull against the brain. 2 of the electrode strips are placed over the region of the left motor cortex that controls hand movements, while the other 2 are placed over the left prefrontal cortex as a backup. The electrode strips are connected to a transmitter device that is installed inside the left side of the patient's chest. The implant wirelessly connects to a receiver via an antenna and to a tablet computer mounted on the user's wheelchair. The patient thinks about moving her right hand to activate the electrodes, which triggers the electrodes to send signals down to the transmitter in the chest. This allows the patient to move a cursor with her hand to make an input on the computer screen. If the patient's motor cortex degenerates over time, the backup electrodes placed over the left prefrontal cortex will be activated. To control these electrodes, the patient has to count backwards, as this region is responsible for mental calculation. ALS affects neurons required for voluntary muscle control and often causes complete paralysis within a couple of years. According to the ALS Association, about 6,000 people in the US are diagnosed with ALS each year. There is currently no known cure for the disease. See a story that really should be animated? Suggest stories to TomoNews now.